Welcome back, everyone. I'm Kevin J, DevOps consultant FE Code. We are here today with Oren Ayende, and he's going to take us beyond the black box. And without any further ado, over to you, Oren. And
Thank you very much. So I'm here today to talk to you about how do you handle it when stuff breaks in production and you need to fix it. And that's an interesting issue because for developers, for operation teams, the key aspect that you care about is making sure that everything works. And that's great. It works wonderfully. But what happens when you have too much complexity? What happened in the cases where you go into a system and there is an issue and you have no idea what's going on in there? So I'm Oren Eini. I'm the founder of RevenDB. I have been debugging stuff in production since 2005. Actually, longer than that. I don't know if many of you remember, but it used to be the case that you would go an FTP into a production website and hit a five and change something and hit a five and change something, and it would do everything in production. And that was a horrible time because you would literally mess up with production and people would notice. Um, Sometimes you still have to do that, but we want to avoid that as much as possible. So let me give you a scenario. This is a real scenario that happened to us multiple times. And the phone ring, the support helpline is saying, "Hey, we have an issue. This is a big customer. We have to fix something. Go." And there is a really important issue here. We have no idea what's going on. Now, I'm not talking about no idea what the solution is. I'm talking about no idea what's going on. What's the error? Where is it happening? What's the system that generating the error? Consider the case that an application has been running in production for a few years and it's a mission critical system. It's been working just fine. And as things happen, people leave. The person who own it, on paper at least, is currently off. They just had a baby, they're on vacation, they're sick, whatever. And it is still a mission critical system. And it breaks. And the administrator in place is going to look and say, what is the nearest thing? What is the nearest thing to the system that I can blame so I can give them a call and see if they can help us? And that's how we ended up handling a, a non-trivial amount of support calls where we pick up the phone, we have a problem with our system, we think it's related to what you're doing, you need to fix that. And the problem here is that I have zero idea what the system is doing, not from a business perspective, not from a technical perspective. Sometimes I don't even know what the issue here, and the person on the other side is just as blind. There is a really good list that is called the fallacies of distributed computing. And fallacy number six there is one administrator. And in any real world system, we are talking about something that is far more complex. There is no one administrator and no one understands the full system. So how do we deal with that? What do you do at this point? And just important, there is a time pressure. Someone is breathing down your neck. So the first thing that I would say that you want to do is figure out what the actual problem is. If I'm looking at something like this, where there is an error, sorry, I have zero way to fix that. Nada, nothing. And I have to understand what the actual problem is. And for some unimaginable reason, even when we get support calls from developers, it didn't work. What did you try? What didn't work? How did it work? Did you get wrong results? Did you get an error? What was the error? Oh, you got an error with this message. What was the full stack trace? Because there is an inner exception that you missed explain everything. The part that kills me is that I've been doing that for quite a while, and I put a lot of effort into error handling and not so much error handling as making sure that when an error happens, you can trace it to the actual problem. So in many cases, if you just give me the full information, I can tell you what's wrong. Oh, the certificate isn't updating in the cluster. Okay, great. Did you check the file permissions on the certificate file at the operating system level? And how do I know that? Because it says no permission when you try to update the file. As easy as that. If you give me the information, I will be able to tell you that. Now, it's easy to say, give me the information. And sometimes they actually give it to you. But remember, we are under time pressure. We need to be able to provide as soon as possible a solution to the user. And there is a very simple solution that works in many cases. Turn it on and off again. And that works. That works wonderfully. And it masks the problem. And it would come by later, hopefully during normal business hours. More likely around 2 a.m. on a Friday. So other things that I saw that people are doing is, oh, there's some configuration options. Let's see if I mess something up there, if it would work. That typically also involves restarting the system, so it looks like it's working. And I found that shouting at the computer with a great deal of frustration tends to be quite helpful, at least for my stress levels, but not necessarily a viable technical solution. Now, the typical way that we would want to fix something like that is look at the log. And surprisingly enough, that's generally a bad idea because the log is too verbose. You're drowning from the amount of details here. And who has written the log file? If it's not you and you're looking into this and trying to understand what's going on, then I have zero idea what this actually means. On the other side, you may have log files just contain errors or something like that without the prerequisites to understand what's going on here. So we have two tails and two verbose at the same time. And in many cases, what the log file is giving you is application knowledge. But the problem is a couple of layers down. So logs can be absolutely invaluable. And printf is a great debugging technique. But in many cases, they fall short, especially because to properly analyze the log, in many cases, you have to sit and process. That can take quite a lot of time. So here's the problem. I'm running in production and something is wrong. And I'm not on the machine. I'm not working in my own environment with all of my toolings, the ability to do whatever I want. I'm remote. I'm typically on some sort of a Zoom call. I don't have access to the production machine. Sometimes they have a problem happens in a machine that you have to go to two or three different environments just in order to see. And that sounds like a silly issue, but you end up with a system that has about this much screen real estate to see what's going on because you log in into the ops environment and then you log into the actual machine and then you jump off to the actual server that has the issue and you end up with small real estate to actually work on that, and that's an actual problem, which sounds ridiculous if you think about it. the size of the screen real estate, that means that I have an issue with doing that. Because this is a production environment, I cannot install a lot of tools. I cannot attach a debugger. This is running in production. I, in many cases, can make very little modification to the environment. And there are also other considerations. They may not be able to show me the data. It might be healthcare related, sensitive information, those sort of things. In some cases, they refuse to tell me what the error was. At which point I told them, okay, I refuse to tell you what the solution is because that's the same thing. If you hear the deep level of frustration that I have from this situation, you can not even begin to appreciate how much this is an annoying scenario to be in. And the whole idea is that we want to, as much as possible, alleviate that. So let's see how we handle that. The first thing that we have to do is figure out what the problem is. And there are all sorts of different issues that you can handle. So let's look at what is probably the easiest thing. Too much memory. And you know that you get too much memory if you get something like those errors. And why is it easy? It's easy because it's observable and repeatable. It's not so easy when we talk about how you handle that. So let's talk about something simple. I'm doing this particular action and I'm getting out of memory error. That's trivial to understand. Okay, so there is this input, cause allocation of large amount of memory. Great. So somewhere along the way, I'm doing the processing. Maybe I'm trying to load a 10 gigabyte JSON file to memory, something. Doesn't matter that much. But I can follow that line of reasoning. I can maybe break the operation apart into a distinct value, something. It gets more complicated when we have growth over time. So slowly the system uses more and more memory. Now, I'm going to use .NET here a lot as my example because that's the thing that I'm most familiar with. There are similar tools and operations for other things. Now, just to give you some idea about the Revit complexities, there is this wonderful book by Conard that talks about everything related to .NET memory management. It's 1,100 pages. I have it somewhere in the office, and I had the course to look into that multiple times. It's really useful, but it is the exact opposite of what I want to look at if I now under the gun and have to fix a production problem. This is something that you would read in order to understand how to have the prerequisites to fix that sort of issue. So the first thing that I want to do, I want to understand what's going on. And let me show you how that works. So right now, you can see this is htop. So this is the htop command. This is basically the most obvious simple thing you can have. And I'm going to use this as my example. And you can see that there is quite a lot of interesting information right here. So how much virtual memory I'm using, how much memory is resident. The other things aren't that important. This is the amount of CPU that is being used. This is the amount of memory that is being used. Not really that interesting in this regard. But in many cases, this is sufficient for me to actually understand roughly where am I at? What's going on? It turns out there is a lot of details of memory. Again, 1,100 pages book. And at the same time, you have a lot of facilities in place. So for example, if you're running on Windows, this can give you a lot of information. And just so you know, there is a lot of stuff here. So just by looking into that, and all of those Rocky set memory delta, all of those are profoundly interesting for us. There is the VMAP. This is a tool that you can run on Windows, and I think there is also one for Linux, and that gives you some really interesting information. That allows you to point it to a process and show you what data. So this is the binary data. Here's some memo map files. Here is the size of the heap. If you run in a .NET application, you get the manage heap, etc., etc. Now, if you're running on Linux, you have this interesting detail. Let's see that. Uh, so I have this guy. Now, what you see here, it's really obtuse to see this, but you can see all of the memory ranges that were allocated by this process. And if you get to the point where you're reading that, you're off the deep end usually. But this gives me a lot of information. Now, I can also use this tool. I'm installing gcdump. Sorry, -p. And it takes a gcdump. And now I can do this and report to 22. Now you can see something quite interesting. Here is the total size of the GC heap. You can see what's going on. So here is what I have in the system. Now, this is something that I can do on a production system. And that tells me quite a lot. For example, if I go here, this is the instance equation. I'm going to do some work. I'm basically going to increase the amount of data that I have here by a lot. I'm going to RM20. Okay, for some reason, it doesn't like me very much. We open a new. Okay, RM20. Oh yes, that was here. Okay, doesn't matter then. .NET gcdump. Collect. So now I'm doing this. Now I'm running this while it is doing some work. And report. See that it's changed. And I can see exactly what is taking a lot of memory. So using the maps here, that gives me rough overview. This is similar to this. Where is the memory going? Using this give me all of the managed memory, and I can get a lot of insight out of this. Um, just by looking into that. And that tells me what do I have in place. There are more sophisticated tools that I can use. I can create a dump and process that. And then I can follow, put that into a profiler that would do a lot of the work for me. There is the .NET memory profiler that does a great job there. There is the dot memory from JetBrains that also does that very nicely. But the whole idea here is that again, you're under the gun, and in many cases, the user cannot send you a dump of the data because again, sensitive information and all of those sort of things. Now, let's look here. We are using too much memory, and we're going in blind. Sometimes I don't understand. In some cases, users are calling us and saying, hey, there is an issue here with your database. But in many cases, the issue is, hey, we're using your database in our application. It's consuming a lot of memory. And now you're going into a code base that you're utterly unfamiliar with and have to figure out what's going on. And one of the easiest thing that you can do, you go into this and you start by looking at the hotspot. Oh, I can see there's a lot of bytes. Do I know why we have a lot of bytes here? What's going on? Those sort of things. For example, this one I actually know what's going on. I can also take GC dumps over multiple time frames and
Um,
see. Yeah.
Oren, I'm sorry to interrupt. I was thinking, so when it comes to command line, if you could increase the font in command lines, that
Oh,
would be
oh,
wonderful.
absolutely. Yes, I'm very sorry. You're absolutely correct. And is this better?
That's way better. Thank you.
Okay. So you can so you can see here how that works, and I can get good result in this regard. And for some reason, when I'm using the more command, it's killing me. It's killing the terminal. Let's see if I open a new one. Okay, that's good. So so you find with the hotspot, in many cases, you can say, oh, I can see that you have I don't know, 100,000 of users objects in memory. Is it expected? Is it not expected? Is it maybe you throw that into somewhere and what's you going to do? Another thing that is really interesting, you can do this. Uh, this is another .NET tool, and in a few seconds, you're going to start looking into some interesting numbers. If you have a large memory utilization, you want to watch this. How much memory do you allocate per second? And this is really interesting because I'm not allocating that much memory. So let me force it. Uh, so I'm going to do this. And what this would force it to do is create something new. But this also forces to allocate a lot of memory. So in a few seconds, we should be able to see higher allocation rates. Apparently, it's doing that quite well. Uh, let's look into this here. No, I'm showing you only the default items, but you can see there's quite a lot of details here that you can look at. Strings is one of the biggest issues in for applications. So you want to look into that. You want to look into the root cause as much as possible. Now, here's an interesting question. What can cause memory growth over time? And the issue here is what couldn't. And, uh, and that's actually really funny. So the easiest thing is you have a memory leak. And in a managed language, Java, C Sharp, Python, those sort of things, you generally don't think about it. But it is quite easy to get to that point. You have events, lambda capture that capture more than you would expect. I would talk about those specifically in a bit, but I want to talk about fragmentation for a while. What is fragmentation? You allocate memory in a particular pattern, and then you release some of this memory. But the pattern of allocation and deallocation means that you can no longer use that memory. Imagine that the classic example, I allocate 100 100,000 buffers of 1 kilobyte each, and then I free every second one. So I have 1 kilobyte free, 1 kilobyte free, 1 kilobyte free, and now I'm going to try to allocate a 2 kilobyte buffer. Conceptually, I have that memory. I have 50,000 kilobytes that are free, but I have no consecutive 2 kilobytes. So I have to allocate additional memory. And this is a huge problem for long running systems. And fragmentation is a core issue for memory allocations. Other things that can impact the growth is you're doing something long in a finalizer. And why does it matter? Because let's assume that you did not properly close a file. So you did something like this. So what do you think would happen here? What would happen here is that you created a file, you wrote to it, and then you're done. Here's what's going to happen when you're running that in C#, for example. The file has a finalizer. This was not actually written to the file. This was written to the in-memory buffer. As part of the finalization of this file is actually of this file instance is actually writing that to the disk. What happens if that takes a while? What happens if this is a network path and the actual writing takes 1 minute? Well, there is one finalizer queue. So the finalizer is just going to sit there and wait, and all of the items that need to be finalized are going to be stored, and they cannot be removed from memory until they have been executed. Now, the issue here is that this isn't a classic memory leak. If you will wait, it will fix itself. But now you need to understand what's going on. And again, that is those are one of the sort of things that you see happen in production. And the user may have leaked a bunch of files and like 10. They are slowing down uh, they're slowing down the finalizer for other instances, and those instances may hold quite a lot of memory. For example, they may hold native memory. But by the way, native memory utilization in managed application is a huge issue. Have you notified the garbage collection that you're actually using this memory? So it can take that into account in the consideration of when to run GCC or not. And finally, we have the concept of really complex object graph, which has a lot of back and forth. And that can massively increase the amount of usage of CPU usage that is required by the GC to operate. And we'll see an exact example in a bit. Take a look at this code. There's not a lot of code here, but let's see what's going on. So we have a path to a large file here. Sorry for the typo. And if we have a debugger, then we log that, and we use this method to avoid this concatenation if we're not debugging. We are registering for an event, and we are doing a long operation, and if the user has been removed, we cancel cancel the operation. It's pretty easy to understand what's going on, right? What's the problem? This is a leaky code. This leaks a lot of memory. How does it happen? Well, let's look at this guy. This register for an event. What does it do? It creates a lambda that capture the this pointer, the cancellation token source pointer, so it can use that. And it's add that to the event, and then it is never removed. So over time, this is going to accumulate all of the user's control instances that happen. This is a classic example of oops. And you know what? Okay, I can fix that. I would add a try finally here, and when it is done, I would remove the event. Not crazy about it, but not that complex. And I'm running that, and then I realize that I still have huge amount of memory being used, and I don't understand why. And then I realize that look into this. I have a lambda here, and I have a lambda here. And the way that C# works is that each method get a single lambda context value. So even though I'm not seeing that, the context value for this method also capture the large text. And you know what? That kind of sucks because now I've extended the lifetime of this significantly. So as I mentioned, I'm just giving you the highlight for fixing memory issues, and a book is doing a lot more, but just those relatively simple things, the ability to look at the GC stats, the ability to look into this, into what is actually taking the memory, is a huge boost in trying to understand what's going on. Now, let's talk about scenarios where we have large number of high CPU utilization. And again, I'm going to start from the most simple of tools. This will tell you if I have a high number of high CPU utilization. Let's try to run this. And I have a relatively powerful machine, so we're not going to see too much. But okay, this is taking some CPU. What do you do now? I can, at this point, what I'm looking at right now, I'm looking at the process view. I can ask it, okay, press Control capital H. One, look at the threads. So now I can look and see where exactly the CPU goes the at the thread level. And if I did a good job and named my threads appropriately, I can see where all of the CPU is going. At the same time, I also have a lot more information. I can look at this, a trace. So let's see how that would work. And basically, this is now running and doing some stuff. And I'm going to let it run. I'm going to do whatever operation I need here. And you can see there is some work that is being done. Not really that interesting. I'm going to exit that. And this is what I want. Now I have report. This gives me the top 5 most used um, top 5 most used functions. And I think I can do this and hopefully get more. In this case, I'm not seeing too much because this is showing the amount of time that I spend in each functions. And most of them are basically waiting for something to happen. For example, here I'm waiting for the console to happen. Here I'm waiting for some thread or something. Doesn't give me that much information. Do also this and format. Now I can ask it. Second, I need to get the Windows path for this. Now I can go here and load the file. And I'm going to increase a bit. It does not want to let me increase. So I'm going to show it like this. Okay. Now you can see here, I can choose the particular threads. Now I can see what run and where. So in this case, I'm waiting for some low-level semaphore. So this is a thread that isn't actually doing that much. If I'm going to look at, second, this thread, you can see here is the scheduler ticking. It's waiting for this and waiting for some other things. So the whole idea is that now I have a way to get a good trace of what's going on. Again, I'm doing that in the under the assumption that we have as little support and tooling possible. I'm on a phone call. Whatever I do, I have to do it as soon as possible. There is also the perf command that you can also use in Linux. I like .NET Trace. I think that's much nicer system. If you can, an actual profiler would probably give you more information, but just this ability to see what's going on give us a tremendous boost in understanding. Okay, I already show you the counters. It's a really interesting deal that you can write your own and you can expose exactly what's going on in your system. Uh, this value, percent time in GC, is super important. Why is that? Because in many cases, if you're using if your code is generating a lot of garbage, you would spend most of your time dealing with the garbage. And then you can see that percent time is in GC is 95%, which means that the 5% of the code that actually does some valuable work is generating so much garbage that the rest of the time just goes into cleanup. I mentioned that highly connected graphs are a problem. And it turns out there are many, many cases where this is a big, big problem. For example, if you use a thread local value, internally this is represented as a linked list, and that can generate hugely complicated object graph if you're running that over a long period of time and you have threads that are coming and going. And because the GC course is linear to the number of reachable objects, you have to traverse all of the reachable objects. Now, here is a very simple thing. I need a queue. So I can use either a queue of string or a linked list of string. And in both cases, I'm adding to the front and popping from the back. As simple as that. Why does it matter that, what does it matter that whatever I'm using a queue or a linked list? Both cases, the cost of operations is O1. Well, it matters because a queue internally is implemented as an array. So there is not a lot of pointer chasing. Linked list, on the other hand, is implemented as a linked list. So you have to do a lot of pointer chasing. And that design decision can have a huge impact. Not because of your code, because what the GC is doing because of the data structures that you chose. Um, this is slightly harder, but still okay. You have a hang. The system stops responding. And typically that's easy. You go and you look at the stack traces. So let me show you how you can do that. Uh, Install dump. Okay. Select. Uh, was it 16 something? Okay. So now it wrote a dump file. Okay. Now I have a lot of commands and things that I can look at, but this gives me a lot of low-level details about the memory, the garbage collection, stuff like that. That's too complex. I can ask it to give me a statistics. You can see I have lots of bytes, lots of strings. This is the number of objects. This is the size of the total size of the objects. If you see a lot of stuff here, that can indicate that there is a lot of fragmentation. See, there should be something about stack here. Da, da, da. CLR threads. This is all of the CLR threads that you have. Now you can do this CLR stack, and that tells you exactly where everything is happening. So if you have a deadlock or some sort of a block hole, you can see in here, I'm stuck doing this thing. And that's sufficient in most cases to figure things out. In other cases, you may have some sort of a retry loop or something like that. And again, just being able to go into the system and dump the state and start looking at the stack traces of each one of the threads would be sufficient. Now, if you have an async operation, that makes things a lot more complex. At that point, you may have to look into this. There is some around here, there is a task state, and you have to look at the task, and this is truly gets to the point where you have to wear this hoodie and sit in a dark room and have hackers running in the background. Notice, by the way, something really important. Finalizer queue is a great example of what's sitting there and waiting. And if you see huge number of items there, for example, you may have, I have quite a lot of files here. If you see something here that in the tens of thousands, that usually indicate something wrong with the finalizer. So now you can do something like look at the threads, look at the CLR threads, figure out which one is the finalizer thread. So this is this one. So no, sorry, that's not the one. You have to switch the thread
Uh,
to.
Sorry to interrupt.
Yeah.
time here.
Okay.
So
I will move
yep.
on then. Other things that makes it more complex. It's slow. It still works, but it's slow. So the first thing that you have to understand is what's the root cause? What's going on? Is it CPU? And if the CPU, then go and look at what's taking the time. Is it the GC? Is it the finalizer? Is it that you're doing something strange? If it's IO or network stall, you have to look at the cloud in many cases, see whatever, if you're running on something that is burstable, understand what's going on. This is a thread pool convoy is a huge issue. If you are mixing async and synchronous operations, sometimes you don't have you have a lot of operations to run on the thread pool, but some of the operations are synchronous alone and takes a lot of time. So basically, created a traffic jam for the thread pool. Uh, and in this case, look, and I already did this demo, and you can understand exactly what's going on, what you're doing here. For example, run the thread pool command and see what's going on. This is nasty. It sometimes fails. And I want to give you a real world example. Every 15 to 30 minutes, there is we cannot connect to the server. It just times out. If I'm on the server, everything is fine. I'm working properly. All of the metrics says I'm good. But even when I'm on the server and trying to connect to itself during a 2 minute period, I cannot connect. And this is a big mystery. And it took a lot of time to figure out what's going on. And I just want to give you the final solution to understand what happened there. This was an Azure machine on a private network. It was using X59 certificates, and it has this CRL, which is certificate revocation list, which meant that every time that we opened this certificate, we had to ping this URL. This is a Let's Encrypt certificate. So this is a fairly popular system. Every time that you open the certificate, any Let's Encrypt certificate, the data frame, you would hit this URL. Now, because this was a private network, the private IP was routed through a shared Azure IP. And there are a maximum of 65,000 ports possible. Now, going back to explain how TCP IP works. You have the source IP, source port, destination IP, and destination port. Here is the destination IP and destination port are fixed, whatever this IP resolved to, and port 80. So the source IP was also fixed. This is the shared IP that I have. And the source port is something in this range. But because this is a popular destination, then there were a lot of other services, other things that also try to hit that. And every once in a while, we would hit the scenario where we would try to reach the remote server, but it was closed and it was on a time wait. So it thought that we close the connection and this is just a random packet. So it ignored that and the connection would time out. It happened every 15 to 30 minutes, depending on the cache settings and what other activity was there, not on my machine, but globally in Azure. And there is Leslie Lamport, who is hugely influential on a distributed system computing entirely. And I really love this quote. Fell off a computer you didn't even know existed, and your system is unusable. This is the nastiest sort of problems to look at. And, and you can see that sometimes this is slow, and 1 in 1,000, 1 in 10,000. How do you figure this one out? Uh, in many cases, this is because of something like a buffer. And a great example is what is the lookup time to a dictionary or a hash table? And you can see it here.
I'm
And how?
sorry. I'm sorry, I have to cut you off here. We
Okay,
have a session
okay,
starting the same
okay.
track in a minute.
Uh, okay,
So
so I will just give you the final details. There are a lot of tools that you can use. And if you have questions, I think we have backstage or afterward that we can discuss.
Awesome. Thank you very much, Oren.
Okay.
We will continue as soon as this session ends, and
Okay.
glad
And
glad.
sorry, and I'm sorry for running long. I'm
Oh,
very enthused about this topic.
nice to see your enthusiasm. Have a great
Okay.
day.
Thank you.